Hi everyone, welcome back to another Practice Together session. Today we are going to employ a fast and effective technique to find an equation of a tangent or a normal. If you're ready, let's jump right in. Now a typical question goes something like this. Find the equation of the tangent to the following curves at a particular point. We first have to understand what is a tangent. It's basically a line, but this line is a special line. It meets the curve at only one single point. Now the question says find the equation of this tangent. So in order to do so, we need two basic ingredients to get any equation of a line. The first ingredient, the point or coordinates that the line passes through. The second ingredient is the gradient of the line itself. This can be derived by finding the derivative of y, which gives us the gradient function of y. Simply put, when we differentiate y with respect to x, we get the gradient function of y. So we already have one of the ingredients, which is the point, denoted by 1, 5. So let's try to find dy over dx. So by differentiating y with respect to x, we have 8x plus 3. Now do check out the basic concepts of differentiation linked in the description box below if you are not familiar with differentiation. So what we can do is that at the point x equals to 1, the value of dy dx is equals to 11. Now what this means is that the gradient of the tangent is 11 at the point where x is equals to 1. So let's try to introduce the equation of the tangent right now. It is simply y minus 5 equals to 11, x minus 1. Now this is a very easy way to express an equation. This came from the gradient of a line where you have y2 minus y1 over x2 minus x1, which gives us the gradient of a line. By bringing the x2 minus x1 to the right hand side, we can actually derive any equation given a gradient and coordinates. So simplifying further, we have y minus 5 is equals to 11x minus 11. And making y the subject, y is equals to 11x minus 6. So there you have it. This is the equation of the tangent. Now let's try to do one more question so that we can solidify our concept of finding the equation of a tangent. We have y equals to square root x squared plus 8 at the point 1, 3. Now let's try to find dy dx using the chain rule. So this will be equals to half x squared plus 8. Remember, retain the original function, minus 1 to the power, which gives us minus half, and differentiate whatever terms that is within the bracket, which is 2x. By simplifying further, we will have x over square root x squared plus 8. So at x is equals to 1, dy over dx is equals to, let's substitute x equals to 1 into dy dx, we will have 1 over square root 9, which gives us a value of 1 over 3. Now, we have the gradient over here, and we have the coordinates of the point where the line passes through. So we can then form the equation of the tangent using this format, y minus 3. It always begins with a y and always has a minus in the center. It's equals to 1 over 3 and x minus 1. Y minus 3 is then equals to 1 over 3x minus 1 over 3, and 3y minus 9 is equals to x minus 1. Now I have multiplied 3 on the both sides of the equation so that I can eliminate the fractions, and we can conclude that 3y is equals to x plus 8. And so this is the equation of the tangent. Now let's try question 2, where we will need to find the equation of the normal to the following curves. Now to understand what a normal is, we can take a look at the diagram here right now. It is actually just a line. However, it is perpendicular to the original tangent that we have seen previously. So the key word is perpendicular to the tangent. Now finding the equation of the normal is similar to the previous question. All we need to have is the coordinates of the point where the line passes through and the gradient of, in this case, the normal. So we have dy over dx equals to 4x plus 6. The gradient of the tangent at x equals to 2 is equals to, let's substitute x equals to 2 into dy dx, which will have 8 plus 6 and is equals to 14. Now take note that this is the gradient of the tangent and not the gradient of the normal. In order to find the gradient of the normal, we will take minus 1, it is always a minus 1, divided by 14. This came from the formula over here, where m1 multiplied by m2, where these gradients are perpendicular to each other. When we multiply them, the value is minus 1. So if you want to find the gradient m2, for example, all we need to do is to take minus 1 divided by m1. Alright, so putting it together, the equation of the normal, we have y minus 15, which is the coordinates of y, is equals to minus 1 over 14, put the gradient over here, and x minus 2. Simplifying further, let's try to multiply minus 14 on both sides of the equation. We have minus 14y plus 210 equals to x minus 2. Minus 14y is equals to x minus 212. Now you can leave the answer as such, but if the question requires you to make y the subject, we can divide minus 14 on every single term. So let's attempt a slightly more challenging question over here in number 3. Find the coordinates of the point where the tangent to the curve y equals to x plus 1 square root x squared plus 1 at x equals to 0 cuts the x-axis. Now this is quite a mouthful, but we can break down the question in 3 parts. The first part, we need to find the coordinates of the point, but before that, we need to get the tangent line to the curve. At this location, x equals to 0, this tangent line will cut the x-axis at a particular coordinates, and we need to find that coordinates. Alright, so in order to get the equation of the tangent, remember we need 2 ingredients. The first will be the coordinates where the tangent line passes through, and the second will be the gradient of the tangent. To find the gradient of the tangent, all we need to do is to find dy over dx. Let's try to use the product rule, because in this expression, it is a product of 2 terms. You get the second part, which is x squared plus 1 power half. Differentiate the first part, which is 1. Product rule starts with the letter p, so we put a plus. Keep the first part, x plus 1 over here, and differentiate the second part using chain rule, which is half x squared plus 1 minus half, and differentiate the terms within the brackets, which is just 2x. Now let's try to factorize x squared plus 1 power minus half, and this will be multiplied with x squared plus 1 plus x squared plus x. Simplifying further, we will then have 2x squared plus x plus 1 over square root x squared plus 1. Let's try to find the value of the gradient. At x equals to 0, dy dx is equals to, let's substitute x equals to 0 into the expression. We will have 1 over 1, which gives us a nice value of 1. At the same time, remember we need to find the ingredient, which is the coordinates where the line passes through. We will have at x equals to 0, y is equals to 1 multiplied by 1, which is simply 1. Now, having all this information here, let's piece them up together to find the equation of the tangent. So remember, always put y first, minus, always put a minus, and get the y coordinates over here of the point that the tangent line passes through, which is 1. And this will be equals to, put the value of the gradient over here, which is 1, and always continue it with an x, minus, put the x coordinates of the point where the line passes through, which is equal to 0 over here. So we'll have y minus 1 is equals to x. Simplifying further, y is equals to x plus 1. Now let's take a look at the question again. It says that this tangent line cuts the x-axis. So let's try to substitute y equals to 0 into this line over here. The value of x will then be equals to minus 1. Thus, the coordinates of the point where the tangent line passes through the y-axis is equals to minus 1 and 0. Now let's try out the last application question where the normal to the curve y equals to x square root 4 minus 2x at the point x equals to 1 passes through the point P8. So find the exact value of P. Now to start this, we need to find the gradient of the tangent before we can find the gradient of the normal. Alright, so let's try to find the gradient of the tangent by finding dy over dx. We are going to use the product rule because it's a product of 2 terms. keep the second part, which is 4 minus 2x power half, differentiate the first part, which is 1, plus keep the first part, which is x, and differentiate the second part using the chain rule, which gives us half 4 minus 2x power minus half multiplied by minus 2. Factorizing out the smallest term, which is 4 minus 2x power minus half, we can then multiply it with 4 minus 2x minus x. By simplifying further, we will then have 4 minus 3x over square root 4 minus 2x. Now let's try to find the numeric value of the tangent at x equals to 1. So substituting it into dy dx, we have dy dx equals to 1 over square root 2. Now this is the gradient of the tangent. What about the gradient of the normal? We need to take minus 1 divided by 1 over square root 2, which gives us a value of minus square root 2. Now we also need to find the coordinates of the point where the normal passes through. So at x is equals to 1, y is equals to square root 2. So let's put together the equation of the normal right now. So y minus square root 2 is equals to, let's put the gradient over here, minus square root 2 multiplied by x minus 1. We will then have y equals to minus square root 2x plus square root 2, and bringing over the minus square root 2, we will have a plus square root 2 over here. Simplifying further and making y the subject, y is equals to minus square root 2x plus 2 square root 2. Now this is not the final answer because we want to find the exact value of p. So what we can do is that at p, 8, let's substitute all these values into the equation of the normal. 8 is equals to minus square root 2p plus 2 square root 2. Square root 2p is then equals to 2 square root 2 minus 8. P is equals to, let's divide every term by square root 2, which gives us 2 and minus 8 over square root 2. By rationalizing the second term, we will have 2 minus 8 square root 2 over 2. This is because we have multiplied square root 2 on the numerator and the denominator. And we will then have 2 minus 4 square root 2, which is equals to 2, open a bracket, 1 minus 2 square root 2. So there you have it. This is the value of p. If you have any questions or have any requests to go through a particular topic, feel free to leave them in the comments below. Thanks for watching.